Hi, welcome back to section 3 of text course on serverless architectures and best practices. In the last few sections, we have seen what serverless is and what are microservices. In this section, we will dive deeply into micro and nano services. We will explore the differences between them, and we will discuss a particular kind of microservices, which is the HTTP Lambda invocation. And they are relevant because they are the basis of every REST service that you can build in your system. We will discuss also about what are the issues related to Lambda invocation that can affect HTTP responses. And the main of these issues is named Lambda cold start. So let's move forward to the first video about micro and nano services. Hi, welcome back to this video 3.1 about micro and nano services. Here we will discuss what a microservice is and how it differs from a nano service. We will focus particularly on HTTP micro and nano services because they have an effective impact on the size of the request that you send to the service and the answer time and the response time that comes from the service. Finally, we will discuss about advantages and complexities of each one of these approaches. But please consider that micro and nano services are nothing new to you because they both fall under the definition of microservice. So you can talk about a microservice architecture and refer at the same time to micro and nano service. Distinguish them for a very specific reason, which is the point of view of the caller, because we talk about microservices when we have multiple HTTP methods that maps to the same Lambda function that process handles them. On the other side, we talk about nano services when we have one-to-one connection between an HTTP method and a number of functions. So nano services are intrinsically smaller than microservices, but is not true that they are always a better solution. It depends on the size and the structure of the service that you are building. Just to show this more clearly, let's jump to a quick demo and a quick example. We have server folder in which we have created a simple serverless service with serverless YAML that I'm going to show you. The provider is AWS, runtime is Node.js. Then we have hello function, simply prints in the output hello world, and a couple of HTTP events that are, and all of them maps to the same function. To show this to you, please note that you have a handler.js, which is a simple method that prints back, that sends back a message with the HTTP method which it is invoked. I have already deployed that service for you, so we can just call this service using a simple curl command which says invoked with method get. Then we can call that with delete, invoke with method delete. Please note that when using delete and put, we have to pass some kind of ID, because in the mappings you can see that we map to user/ID. But we can also invoke that with post method, and it says that it has been invoked by using post. So here we are having this exact same structure of the services that you have seen before, but multiple HTTP methods have been defined to map the same function. This can be surely a partner that you can leverage when you need a deeper connection between your different methods. So jumping back to our slides, we can discuss briefly about which setting is better. Should we use function handler for each HTTP method? Should we use a pattern like this? So we have to consider some constraints that can make your decision shift. The first one is about domain, because if your domain is gonna change from time to time, if your domain is gonna change quickly, probably having separate life cycle for separate methods can be a good choice. But on the other side, if you are implementing a simple CRUD service in which all the meaning of your methods is deeply integrated, probably leveraging on a microservice pattern can be better. The second constraint is about communication, because whenever you have to pass to exchange data between different Lambda functions, you have to put in place some communication mechanism that can be as simple as directly invoking the Lambda you required, or as complex as putting in place a Kafka stream or an enterprise service bus or a message bus or whatever. So communication can play a role in making you shift toward microservice instead of nano services. But on the other side, the life cycle can be really an issue when you have a lot of coupled functions, coupled services. And finally, security could be a problem whenever you want to secure the functions, the code function that are called by your service. So you have to put in place a security mechanism and split or duplicate that across different Lambda functions. So there is not a clear setting, there is not a clear thumb rule that can guide you towards micro or nano services. Just your experience can tell which one is better. My suggestion is, as usually, to start with the fastest thing, the thing that requires less code from you, and then refactor and evolve the code towards the best architecture that you can achieve.